Hi, the chapter is based on probability. Now, what is probability? Probability is the chance of an event occurring in any experiment. When we talk about event, it's an occurrence, that takes place in any experiment. We've got two kinds of events. We've got exclusive events. Exclusive events is basically when two events cannot happen at the same time. Whereas when we talk about independent events, which is the second type of events, independent events, these are events, when they do not affect each other. So when one event does not affect the occurrence of the other one, the other event or other one. However, whether they are exclusive or independent events, if we want to find the probability of an event happening, we're going to take the number of outcomes, in favor of the event, and all of that divided by the total number of possible outcomes. Now, there are clear examples that we can explain when it comes to exclusive events. So we can say something like, for example, the probability of Sam taking road A to go to school is, let's say, 0.7, and the probability that he takes route B to go to school is, let's say, 0.8. Alright? Now, these two events, when you look at them, clearly he either he takes road A or he takes road B, but he can't take both roads at the same time. That's a clear example of an exclusive event. We're going to look at an example of, try to explain what we understand by independent events. And when it comes to this one, we said before that one event does not affect the occurrence of the other one. The probability that it rains is, let's say, 0.3, and the probability that Rina takes or uses an umbrella while it rains is, let's say, 0.9. Maybe she likes the rain sometimes. There is a little probability of 0.1 that she's not going to use an umbrella. But it is possible that while it rains, so probability while it rains and she takes and uses an umbrella is possible. So when that is possible, what we do, we take the probability of 0.3, we multiply by 0.9. Whereas for the exclusive event, probability that he either takes road A to go to school is 0.7. Let's say the other one was 0.2. Okay, what's the probability that he takes either of these roads? So we add the probabilities. So clearly we've got some kind of principles over here. Alright, so what you do, you take the product of the events, okay, especially when it's an independent event. They are independent events. Whereas you take the sum, okay, so sum of the events if it's exclusive, because it's either or. Alright, so now what we're going to do, we're going to come with some examples. So here is a typical example that you may get in the exams. A card is drawn from a pack of cards, and find the probability that the cards is a king, the cards drawn is a king or a queen. Okay, so how are we going to do this? Alright, so if we have the probability that the card drawn is a king, now we know we've got 4 kings out of a pack of cards which got 52 cards. And either we get this or we get the other one. Alright? So the probability of getting a queen, now that's clearly 4 queens, alright, out of 52. And because we can either get a king or a queen, alright, probability king or queen, it's one or the other, both cannot happen at the same time. How would you be able to draw one queen if you're drawing a card, okay, and then at the same time the card is a king? No, it's not. It's either a king or a queen. So what we do, we add these probabilities. 4 over 52 is 1 over 13, and then plus 1 over 13. So we're saying then 2 over 13. Now in this example, a card is drawn from a pack of cards. Outcome noted and card is replaced. Very important information. A second card is then drawn. Find the probability that both cards are red. Now remember, we've got 26 red cards, so probability of getting a red card is 26 over 52, which is 1 over 2. And the probability of getting a second card, remember it was replaced, so we go back to 26 again. There's no 25 cards now, because if it wasn't replaced it would have been 25 over 51. Because the card is replaced, so we come back to the same probability of drawing a second red card. So the probability of drawing both cards red is probability of red times the probability of red, because both events are possible. So we've got then a half times a half, which is a quarter. First part done. Now for the second part, one card is drawn. One card is a king and one card is a queen. So there are 2 possibilities. I'll tell you how. 2 possibilities. And for getting one king and one queen, okay? Right, so the first possibility is that you can get the first card, a king, and the second card, a queen. Right, in the second possibility, you either get the first possibility, or in the second possibility the first card is a queen and the second one is a king. So here we go, two possibilities. Let's look at the first. Let us explore this in detail now. The probability of getting a king and a queen is possible. So we're going to take probability of king times probability of queen. And we know we've got 4 king over 52, alright, times the probability of getting 4 queen over 52. This is the first possibility. For the second possibility, we had either a queen and a king, right, which is then probability of getting a queen first times probability of getting a king as the second one. Again, this is 4 over 52 times 4 over 52. So these are combination of probabilities. That cannot happen at the same time. It's either you take this or that. So what we're going to do then, the probability is going to be equal to then the sum of these probabilities. So we've got 4 over 52 times 4 over 52 plus 4 over 52 again times 4 over 52. And if you were to do that on your calculator, you'll get 1 over 169 plus 1 over 169, which basically comes to 2 over 169. Okay, still on probability, and this time we're going to look at a tree diagram. A bag contains 4 red and 6 blue balls. One ball is removed at random. Anywhere from the bag, its color is noted, but it is not replaced. A second ball is then drawn at random, and the color noted. Find the probability that both balls are blue. The second ball is red. Now we're going to do this by drawing a tree diagram. Suppose if I were to draw a tree diagram for this, for these events. I'm going to start off like this. Okay, and we're going to go somewhere. Right. So this is our first possibility. Remember, we've got, I'm going to call this one red and this one blue. So we got 4 out of 10 red balls and 6 out of 10 blue balls. And I'm going to draw a ball at random, note its color, and then do not replace the ball. Now, we've got a second possibility going like this. Say for instance now, okay, but first of all let's write this as red, blue, red, and then blue. Suppose the ball that is drawn is a red ball. So 4 red balls, 1 is drawn and it's not replaced, so we're left with 3 red balls out of 9 balls. And as for the blue ball, it was not removed from the bag, it was a red that was removed. So we still got 6 balls out of 9. The total is 9, however. And the second possibility, let us say now I do not remove a red ball. The ball removed, let's say, was a blue ball. So as for the red, it's going to be 4 over a total of 9, because now a blue ball was removed. And out of 6 blue balls, 1 is taken away. So I'm left with 5, which is 5 over 9. So that's my tree diagram. This tree diagram is going to help us to find these probabilities. The probability, then, for the first part, now, this is, I'm drawing a tree diagram here. The question might ask you to draw a tree diagram. Then you have to draw a tree diagram. Otherwise, you can do it by other method. If it's not been stated that it's a tree, I normally find a tree diagram very easy, okay, because it illustrates all the possibilities. And so now we want to find the probability that both of the balls were red, so red and red. No, sorry, it's both balls are blue, so we've got blue and blue. What's the probability of getting a blue ball? All right, so if both of the balls are blue, then one blue and another blue. So I got then 6 over 10 times 5 over 9, which comes to be 1 over 3. So here we are, not difficult at all. This diagram is very helpful. And for the second part, the second ball is red. Remember, that's a condition there. Second ball is red. You can get red and the second one is still red. So you can get either red, red, or you can get a blue and a red, or either or, blue and then a red. But these are not possible at the same time. So we're going to add these probabilities. So we're going to say the probability of red, red is going to add to the probability of blue and red. Here we are. In both situations, the second one is red, the second one is red. It doesn't matter if the first one is red, but the second one has to be red. So the probability of getting a red ball is then red, red is 4 over 10 times 3 over 9. 4 over 10 times 3 over 9. Alright, and then you add to the probability of getting a blue and a red, so 6 over 10 times 4 over 9. Right, when you do this, you can use your calculator, of course. 3 times this is going to be equal to 12, and then 6 times 4 is 24, so plus 24, and we'll look at the same denominators. 10 times 9, 10 times 9 is 90, so we're going to divide by common denominator 90, and all of that should be 36 over 90, which comes to 2 over 5. Alright, so here we are for tree diagram. Now our next example is based on a spinner. A fair 5-sided spinner is numbered using the prime numbers 2, 3, 5, 7 and 11. Here's the spinner. In a game, players spin it twice and add the two numbers obtained. Complete the probability diagram. We can see 2 plus 2 is 4, 3 plus 5 is 2 plus 3 is 5, so we're going to add all these numbers up. For example, 5 plus 2 is 7, 7 plus 2 is 9, 11 plus 2 is 13. Okay, we're going to carry on like this, and this is what we came up with. Now we need to find, the diagram has been completed, the first part of the question is done. Find the probability that the total of the two numbers is a prime number. Now we need to find out how many prime numbers we've got. Okay, so I've got 5, 7, 13, that's three prime numbers. Here I've got 1, plus 1 is 4. I've got 1 here, is 5. And then another prime number if we have 6. So I've got 6 prime numbers, so we've got then 6 over 25. Total probability 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times 5 is 25. The probability that it's a perfect square. Perfect square, I've got 4, 9, which is 2 numbers. Then I've got 16, another perfect square, that's 3. 9 again, that's 4. 16, that's 5, and that's all. So I've got 5 over 25, which could be simplified as 1 over 5. In another game, players spin it twice and multiply the two numbers obtained. Okay, this spinner is spent twice and the numbers obtained are multiplied. Without drawing another possibility diagram, write down the probability that this product is a prime number. Product. When you multiply, you can never have a prime number. Right, so if you multiply prime number by prime number, you're going to get something else. Right, like say for example 5 times 3 is 15. It's going to become an odd number or an even number, but it's never going to come as a prime number again. So therefore, the probability that that x is a prime number, that is the product is a prime number, then 0. That's it. So here we go. Hi. As you can see on the board, we're going to look at all the possible outcomes that we get on tossing a fair coin 3 times. This is a very important thing. It's a fair coin. We can have a biased coin. But let's talk about this one, alright? So I think the best way to approach this kind of question is to draw rather a tree diagram. Let's do that. So this is a coin. For a coin you will get a head and then a tail. So these are the two possible outcomes from the coins. You flip it, you either get a head or you get a tail. Right. So let us see. First time. This is a head and this is a tail. And this is your first throw. In the second throw, you get a head and a tail. A head and a tail. Okay. You can get the third throw. And this is also head, tail, head, tail, head, tail, head, tail. So as you can see, this is first, second, third. These are the numbers of tosses, right? If we're looking for, let's say, head, all right, you can have three heads, 1, 2, 3. So you can have, let's say, head, head, head. That's one possibility if you're looking for heads. You can get head, head, tail. You can also get head, head, tail. Okay, head, 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 tail. You can have head, tail, head. You can have head, tail, head. Same, head, tail, tail. So you can have head, tail, tail. And you can have tail, head, tail, head, tail, isn't it? So you got tail, head, head. Okay, so we can have tail, head, head, tail, head, tail, tail, head, tail, tail, head, tail, 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 head, tail, tail, head, tail, tail, tail. Sorry, tail, tail, and then tail. Right, so we've got 3, 6, 8 possibilities. Like I said, you know, I have set the example to look at the number of heads that we're getting. Okay? You can have at most 3 heads. It's the same for the tail, alright? So, but if you don't have heads, you can have 0 heads. So, let's say we're looking for heads, outcome, probabilities, alright? Can we build a, let's build, construct, okay, a probability distribution table. That's what I want here. Okay, so here are the possibilities. If I have to do this, alright, so let x be the number of heads. Right, so this is going to be represented by, let's see, x, which is the number of heads obtained. Alright, we can have 0 heads and all tails. Can I have 1 head only? Yes. Can I have 2 heads? Yes. Can I have 3 heads? Yes. So we're going to look at all the probabilities now. So probability of x, we're getting x. Alright, so here we go. Now, if I don't have a head, I can have all tail. So that means 1 possibility. So 1 over 8 possibilities. Can I have 1 head? Yes. How many there? We've got 1 head. Let us see. 2, 2, 1 is here. 2 is here because there's 1 head here. So we've got 1 here, 1 head here, 1 head here. So I've got 1, 2, 3 of them. So I've got 3 over 8 for getting 1 head. That's our probability on tossing the coin 3 times. Then also, I want to look for 2 heads. 1 is here, 2 heads, 2 heads, 2 heads, and that's it. So I've got how many of those? 1, 2, 3. And again I've got 3. Obviously you're going to say 3 plus 3 is 6, plus 1 is 7, 8 minus 7 should be 1 over 8. Let us check. There's only one possibility of getting 3 heads. If you get 3 heads, there we go. One possibility. So this is our probability distribution table. Okay, that's how we do it. Okay, take care.